Welcome back. So far, we learned a lot of features and capabilities of delta table. But what are delta tables? What is inside the delta table? How delta table works behind the scene? That's what we want to understand in this lecture. So let's start. Let me go to my workspace and I have set up a demo notebook for this also. So let's go to my notebook, attach a cluster and do the cleanup and also do some setup. So basically what I'm doing as part of the setup, I created a dev catalog and I created a DemoDB database, and inside this database I've created a volume. The volume name is files. I created a volume so that I can save a data set in delta format. We know that delta table and delta format data set are the same with one minor exception. When you create a delta table consists of delta format data set plus metadata in your catalog, right? So with that metadata, you can use Spark SQL queries using the delta table name, like select a star from your delta table name. But you can also have a delta format data set without a metadata. It's still delta format data set and it can exist in a directory. And that's what I'm trying to set up here, only delta format data set. So I have access to the directory and I can understand how delta format data set is organized. I'm trying to set up a volume where I will create a delta format data set and we will try to investigate how delta format data set is organized, created, how it is managed and how it works. So in the files volume, which is nothing but a directory, I have created a delta format data set. So I have created a data frame with some amount of data. I'm doing a write format delta mode override at this volume location, right? In the files, I've created a separate directory for this data set and data is saved there. That's all. So we have the data. Let's look at the data directory to understand how delta format data is stored in the directory. So how do you check the delta table data directory? You can use %fs, right? %fs ls and go to the directory and try to list what do we have here. So what do we see here? We see one underscore delta log directory and all the magic happens inside this directory. So this is the directory which defines the delta table, different versions of the delta table. We will go and look what is there inside this directory and try to understand that. But other than that directory, what else do we have? Everything is like your Parquet files, right? It's snappy compressed Parquet file. So all these, I have 10 rows here. So 9 Parquet files are there. So my data set is saved as Parquet data file. And there is a delta log directory where some information, some additional information, metadata or transaction logs or version information, these kind of things are stored in the delta log. So that's what makes a delta table or delta format data set, right? This is all we have in the directory. Now to understand it further, we have to go inside this delta log directory. So let's go inside the delta log directory and try to see what do we have there. So %fs ls and we go inside the delta log directory and see what do we have there. So there is something temp path dir. Let's ignore that. And other than that, we have two files. .crc file and .json file. A weird file name, right? JSON file name is 0000000 something. CRC file name is 0000 something. So what is CRC file? It's a, I guess, cyclic redundancy check. It's a checksum which defines the correctness of the data. So we ignore that, but all the magic is happening here in the JSON file. So JSON file stores some information about your delta format data set, and the file name is always equal to the version number of the data in your delta table. So this file 0 represents version 0 of the delta table. Now let's do a delete operation on this delta table, right? So let's do a %SQL and delete from this delta table or delta dot directory name. Without a where clause, delete is dangerous, so let me add a where clause here. So here is my where clause. So I'm deleting from this delta table some records where this condition is true. Let's delete it. So delete is complete and it impacted 843 rows. Now let's go and look at the delta log once again for my table or for my data set. So we come here and look at the delta log once again, and now I can see version 1.json and version 1.crc. So version 1.crc is a checksum for the version 1 data files, and version 1.json defines what is version 1, how we arrive at the version 1. All the details are here. So we will go inside the version 1, but before going inside this JSON file and try to understand what is there, let's list the delta table directory once again. So I'll simply do fsls on the firecalls tbl. So let's see, 15 rows, right? I did that list initially here, right, when we created the delta table initial, and I saw 10 records. 10 records, one is for delta log directory, and we had 9 Parquet files, right? So my data was stored in 9 Parquet files. Now what I did on that, and this was the version 0, right? And then I did the delete statement, and after delete I deleted 843 records, right? And after delete, if I again look at my files, now I have 15 rows. So you leave one delta log directory, I have 14 Parquet files. What is happening? I mean, I had a data set, maybe 10,000 records were there, that was made up of 9 Parquet files. I deleted 843 records. So either I should have same 9 files modified, or I should have less files, maybe some data is deleted. But how come 9 data files are now changed into 14 data files, right? So now total we have 14 data files. So out after 9, 5 new files are created. I'm not inserting data, right? If I insert some more records, some more data into that table, I can expect that some new data files will be created. But I'm deleting, and still I see 5 new data files are created. So what is happening? How delta table works? What delta table is doing? So to understand that, we will have to look at the JSON for version 1. So can we query this JSON? Spark is super smart. We can do SQL directly into on a table. Select a star from JSON dot and then pass the location, right? So in this directory, I can go to maybe delta log directory, and then inside that delta log directory I can look at the JSON 1.json. So 1.json is for transaction version 1, delta table version 1. If you have a doubt, you can do the history, right? So let's do the history on this delta table. On this delta table, let's do the history. %SQL describe history on this delta table. And we see version 0, version 1, version 0 was initial data write, and version 1 is created after the delete operation. So we have two versions, and that's why we see two JSON files here. Version 0 JSON file defines what is version 0, and JSON 1.json defines what is version 1. And that's what we want to understand, how it defines version 1, why I got 5 new files created out of 9 old files for a delete. So let's try selecting this, and this is how the JSON file data looks. So we have an add column, then some commit info, and then remove column, and that's all for now. For this transaction, for every transaction, JSON file structure may be little different, but this is the typical structure. So I have add column and I have remove column. So how many records are there in the add column? All that is null. 1, right? 1, 2, right? 3 and 4 and 5. 5 records for add column. And what are these add columns? It is saying this is the new file which are added for version 1, right? Similarly, these 5 records in the add column, they represent 5 new data files that are added for the version 1. For version 0, I had 9 files. For version 1, I did the list and I saw 14 data files. So 5 files were additional, and that is what defined here. These 5 files are created for version 1. So when we want to read version 1, we will have to read these 5 files. And what is there in the remove? So in the remove, we have some files listed here also, right? So how many remove are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 files are removed. So what are these 9 files? These are the same 9 files for version 0. So what this 1.json is defining? 1.json is defining that if you want to read version 1, read all the files from the directory. Make sure you are reading these 5 files and you are not reading these 9 files. Difference is the 5 files. So for version 1, read these 5 files and do not read those 9 files. So for each version, Delta table is recreating the data set. Why? What I did, I had a table and we had 9 data files. I wanted to delete some records and 843 records were deleted. So what delta table will do, will go look into the data files, try to read all those data files and find those records which we want to delete, which are matching with my where condition, and delete those. So delete those, and whatever is the result, rewrite that result as version 1. That's what it is doing. So deletion also reads old data set, removes the deleted records, rewrites the new records as new data files. If you are doing update, that also does the same thing. Read the previous version data set, update the records in the memory, and write the new versions of dataset as new data files. So every transaction is writing some new data files. It is possible that some old data files are not impacted. I want to delete some record and my where condition is like that uh, out of 9 files only 3 files were impacted. So my records that I want to delete were found in only those 3 files. So what it will do, it will rewrite those 3 files after deleting those records. Remaining 6 files will remain untouched, and accordingly this JSON file will have the information that if you want to read version 1, these are the new files added for this version, these are the old files removed from that version, and everything else which is untouched. So read all those files and you can read version 1. So that's how delta table works behind the scene, and that's what you can see in the delta log file. So one thing should be very clear in your mind, that in delta table it looks magical. You can delete, you can update, you can merge, but behind the scene it's not going and deleting specific records. It's always taking the data, deleting the data, and rewriting the entire data set as a new data file. That's how it is doing. They do it in very efficient way, so it works pretty fast, but ultimately we are reading the file, removing whatever records we want to remove, or update those records which we want to update in that file, and then write a new data set. So every transaction on delta table creates a new data set, new data files. That's how delta table works. And that's pretty much all about how delta table works and how behind the scene what happens. That's all for this lecture. See you again. Keep learning and keep growing.